Hello everyone, I welcome you all for the video lecture on object-oriented software engineering. The topic to be discussed is coupling, cohesion, functional independence. And focuses on modular and efficient systems. Two important concepts include cohesion and coupling. These together define the functional independence. Coupling refers to the degree of interdependence between modules. Let us empathize. The goal is to understand user and system needs. Study system requirements and user expectations. Identifying the pain points, such as tightly coupled modules, complex dependencies, or difficult maintenance. Observe how current modules interact and where issues occur. The outcome is the clear understanding of the problems caused due to poor coupling and cohesion. Let us define clearly. It states the design problem. Define issues like high coupling between modules, low cohesion within modules, lack of functional independence. It framed the problem statement. Example, modules are highly dependent on each other, making the system hard to maintain. It is ideate. Generate the possible design solutions. Brainstorm ways to reduce coupling, increase cohesion, improve modular structure. Let us consider layered architecture, service-based or modular design, clear interfaces between modules. The outcome is multiple design alternatives promoting functional independence. Prototype, create a preliminary design, develop a module structure diagrams. Let us define module responsibilities, interfaces, data flow. It creates UML diagrams, and the outcome is a design model with low coupling and high cohesion. What is functional independence? A design principle where each module performs a single well-defined task. It has minimal interaction with other modules. It is achieved by high cohesion, low coupling. Cohesion refers to the degree to which elements within a module work together to fulfill a single well-defined purpose. The goal is to achieve high cohesion. So this is the diagrammatic representation of how the modules are, and the coupling is between the modules and the cohesion is within the module. The types of cohesion is given here, and let us discuss one by one. Coincidental cohesion, unrelated tasks grouped in one module, no meaningful relationship. Example, a module handling login, printing, and database updates. So the diagram represents the coincidental parts which are unrelated in the function A. Logical cohesion, it is a related task grouped logically, selected using control flags. Example, a module handling all input operations. For example, function A dash and A double dash. We have the logic which is grouped to form. So logical cohesion meaning a similar functions grouped together in a logical way. Then temporal cohesion, task executed at the same time. Example, initialization module. Temporal meaning related by time. And procedural cohesion, elements grouped because they follow a sequence. Example, steps in processing a transaction. Communicational cohesion. Operations on the same data. Example, module that reads and updates student records. Like we have a find title of the book, find price of the book, find publisher of the book, and find author of the book. So these are the communicational cohesion examples. Sequential cohesion. Output of one part is the input to the another. Example, read data, then process data, and then displaying the results. Sequential cohesion, example, uh, create a team, assign team name, and after assigning the team name, update the members. Functional cohesion, all elements contribute to one function, single well-defined task. Example, module to calculate tax. The functional cohesion, example, team function, create team, name team, delete team, add member, update member. What is coupling? Coupling refers to degree of dependency between modules. It indicates how closely modules are connected. The goal is to achieve low coupling. The types of coupling given here, let us discuss one by one. Content coupling. One module directly modifies the another. Example, of content coupling, we have the diagrammatic representation here. So if we change a component, which obviously changes the component of another. Common coupling. Multiple modules share global data. Example, global variables accessed by many modules. Control coupling. One module controls behavior of another. It uses control flags. Tab coupling. Two modules are stamp coupled if they refer to the same data structure. This is done often for convenience, but it does present some potential dangers. It exposes a module to more data than it needs. It can create dependencies between otherwise unrelated modules. Example of data coupling. Two modules are data coupled if they communicate explicitly via parameters. This is normal and desirable provided the parameters have been well thought through. So they coupled through parameters. Get customer name and format customer record. With the parameters, account number and then the customer name. Let us compare and contrast cohesion and coupling. Cohesion is within a module, inside a module, and coupling is between modules. Cohesion measure internal strength, coupling measure dependency. And high cohesion is good, whereas low coupling is good. Cohesion improves clarity, coupling reduces complexity. Functional independence is achieved when modules have high cohesion, modules have low coupling. Each module performs one clear function. Characteristics of good design include high cohesion, low coupling, clear interfaces, easy maintenance, and reusable modules. Example scenario, student management system. The good design, meaning separate modules like login, student records, fees management, report generation. Each module has single responsibility and minimal dependency. Let us summarize. Cohesion, which is the internal module strength, and coupling, dependency between modules, and functional independence, which has to achieve a high cohesion and low coupling, the key principle for the good software design. This is a mind map. Thus coming to the end of the session. Thank you.